Hi, Jeremy. How are you?
Hey, James, thanks for the great intro. I'm actually joining you from the Alinda office today, which is in the Yarra Ranges, not in the city of Moreland. Yeah, this is me. That's not about, that's that's reality out there. So anyway, thanks very much. And I should also just say, James, that thanks for taking the time to come to Brunswick to actually go through the Commons and to experience it firsthand and to be able to ask us all of the questions and interrogate us and kind of help educate us too about what is it that that Greater Dandenong needs, when we're approaching a design, through the planning process or through the building process there. So I think it was great to get engagement with you in both ways. So thank you. I should also admit, James, that what I'm going to talk, obviously I'll talk about Nightingale because it's something that's incredibly close to my heart, but I also want to talk about, importantly, a pathway to carbon neutrality, which everyone listening can take home and use themselves. So it's the fundamental principles that Nightingale and that Breathe uses to deliver carbon neutral buildings. And it's pretty straightforward. It's kind of 3 simple steps. So if that's okay with you, I'll just kick off and share my screen and we'll get going. It's just someone needs to enable my screen sharing if that's okay. So I have got a tab that says host disabled participant screen sharing. I'm going to try again.
No worries, Jeremy. We'll the stage, yeah.
Here we go.
Stage support, so it should be good to go in a sec.
Thanks heaps, stage support. Sorry about that. I should have tested that beforehand. My bad. Firstly, I'd like to acknowledge that both the Breathe Architecture Office and the office on which I'm broadcasting now is the lands that belong to the Wurundjeri Woiwurrung people of the Kulin Nation. They're the traditional owners, they're the custodians of the land on which I'm broadcasting from, and it was land that was never ceded. We pay our respect to elders past and present and their continued and unceded connection to land, waterways and culture. So yeah, again, Breathe was founded in 2001. We're just coming up to our 20th anniversary. When we first started, we were one of 6 sustainable architecture firms in Melbourne. When you Googled Sustainable Architects Melbourne, there were 6 of us. The last time I checked, there were 42,000 search results for Sustainable Architects Melbourne. And I think that the great news story there is that every architect in Melbourne now has been educated and is thinking about sustainability. So I think that we're moving in the right direction. It's important to note, however, that our National Construction Code is about 15 years behind most of Europe and about 10 years behind North America. So we can't rely on the National Construction Code to be able to let us deliver sustainable buildings or buildings that will respond to the climate crisis or to our Paris targets. So we have to find ways to go above and beyond that. And I'm just going to frame that for you, and I'm sure that everyone who's been sitting through these presentations will already be across that, but let's be really clear about why the built environment and carbon associated with the built environment is so important, and particularly in Australia. So there's 2 parts to that. So one is, a national construction code behind best practice around the world, and the other is our energy mix, which is incredibly heavy in brown and black coal, and in the future in gas. So Australia has some of the highest greenhouse gas emissions per capita in the world, which is ironic because we're also one of the wealthiest countries in the world. And so, which puts us in the best place to be able to deal with those emissions. And of those incredibly high emissions per capita, buildings consume over half of Australia's electricity. And so the built environment is our single biggest emitter of carbon. So if we have any chance at all of meeting our Paris targets, so if we want to reduce our carbon emissions by 50% by 2030, if we want to get to net zero by 2050, we have to look at buildings and the built environment and how to do that, and we need to do that now. I'm going to talk to you about the 3 steps that we approach at Breathe Architecture to deliver carbon neutral housing, and they're incredibly straightforward. And then I'll kind of answer some questions later for anyone who's got specific questions. Number one, it's 2021. It's the 21st century. We've known about climate change, you know, it's first reported in the late 70s, but we've known for sure since the 90s. We have to take gas out of buildings. There's no pathway to net zero emissions with natural gas plumbed into your building. So step one, build an all electric building in 2021. There is no gas-led recovery on the way to a carbon neutral building. Two, make the building efficient. And so, you know, in a temperate climate like Melbourne, it's very, very easy to make the building energy efficient. And I'll go through a kind of few of those kind of key things in this presentation. And then three, and this is incredibly important, and for any of you listening today that think I don't have the power to change the building that I'm working on, or I don't have the money to renovate my house or change my house, or you know, what can I do today, right now? If you could all take 1 minute and write down this one note on the back of your hand or on a post-it note, make sure you buy 100% accredited green power. And I'll talk about that later, but not carbon neutral power, not carbon offset power, 100% accredited green power. And you can get that from any of your energy retailers, but you know, you could focus on energy retailers that don't have any coal in their energy generation mix, like Momentum Energy, Diamond Energy, OVO, Energy Locals. So any of those, your Power Shop, you know, any of those. But when you're choosing your power, 100% green power. Don't get suckered into one of the other kind of similar options. Again, I'll take questions on that later. So if I go through those 3 steps, step one, take the gas out, simple move. But, you know, working on bigger buildings like apartment buildings, our mechanical consultants, our services consultants, our project managers have always been doing gas for so long. So particularly gas water heating, that it seems like a big step for them. So, and gas cooktops, you know, so let's talk about, you know, how we go about that. So firstly, you know, heating, you know, importantly, no gas, obviously. And we need to understand our climate. So Melbourne is a heating climate, not a cooling climate. And the way that we humans kind of interpret the temperature in a space is kind of 2/3 through radiant heat and 1/3 through air temperature. The way that we tend to try and heat our spaces in Australia is the same as North America and the same as Japan, which is through air conditioning. So reverse cycle air conditioning. In summer, we cool the air, which kind of works because the cool air falls and comes down to the humans. But in winter, when we heat the air, that heat rises and it gets drier and hotter and it gets stratified. So all the hot air sits at the top of the room. And so you've got to really kind of superheat the air to make the human feel comfortable, but the air is dry and it's not a particularly comfortable heat. Whereas if you think about sitting next to a fire or sitting next to a hydronic heating panel using radiant heat, it's actually 2/3 more effective as a human experience than air conditioning. So we use hydronic heating, which is basically hot water running through, you know, our apartment buildings, for example. And then we use a CO2 heat pump on the roof. So you can buy all sorts of heat pumps. Most of them have refrigerants in them, and the problem with a refrigerant is that has greenhouse, you know, warming potential. But if you use a CO2 heat pump, it has no greenhouse warming potential. So we use CO2 heat pumps. It's like an air conditioner for hot water, incredibly efficient. So you know, like 50% more efficient than a condensing gas boiler, but obviously no carbon emissions associated with that. And so we have a centralized unit that heats the water. We pump that through to our hydronic heating panels. And we use radiant heating, not air conditioning, to heat the space. So importantly, if you're renovating your house or you're thinking about, you know, building a house or whatever, you know, don't buy a gas space heater. Don't buy a central gas heating unit. You know, think about electric air conditioning is better than gas. Whatever it is, make sure it's electric, and then buy 100% certified green power, carbon neutral. We also cool in Melbourne. It's pretty easy to cool through passive solar techniques. And so what we mean by that is kind of, you know, Step one is getting the window orientations right. If our windows face north or west, we make sure that they're shaded through summer, but they allow winter sun in to heat the space through winter. But the space is protected during summer. And also we think about, it's really important that we think about the right sizes of windows. So the sizes of windows in bedrooms can be smaller than sizes of windows in living rooms. And in New York, if you think about recently that they've banned glass skyscrapers in New York, because when you clad a building in glass, you've got, all this incredible heat loss in winter and all this incredible heat gain in summer. Whereas, good, well-designed European buildings, even skyscrapers have a window to wall ratio, which is more like kind of, 50% window to 50% solid wall, because solid wall is so much better insulated than glass. So I think we've got to, as architects and city makers, we need to get off our love affair and our addiction to glass and steel and aluminium as a facade system for a building. We need to think about where windows are and what they're trying to achieve, which is light, ventilation, access to views. Cooking. So not cooking with gas, cooking with no gas. So we've moved to induction cooktops. Induction is 40% more efficient than gas. And it's a magnetic field. It only heats up when you put the plate on top of it. It's incredibly effective. For some reason in Australia, there's been a really slow move away from gas, because people think gas is always better than electric. It's not the case. Induction is better than gas. And I think that we also need to accept the fact that, you can get induction woks. But importantly, if you had to choose between preferring to cook with one mode over another or preferring to save the planet or not, surely, the choice is easy. Induction is 40% more efficient. And importantly, with induction, there's no carbon monoxide that comes through, burning gas. So you don't get any, you have better indoor air quality using induction than you would having an internal gas stove or cooktop. Number two, make the building efficient. So for us, that doesn't just mean about thermal efficiency on the building. So all of our buildings are designed to be not 5 stars, not 6 stars, but so we're not worried about what the National Construction Code says. We make our buildings, our residential buildings, to meet a minimum of 7.5 stars on a NatHERS rating. And the goal would be to get to 10 stars, which means you don't need any energy for heating or cooling. And so we think about that when we design our buildings. So we make sure they're thermally efficient, they're well insulated, the windows aren't too big, they're double glazed, the glass is shaded in to the west and the north at the right times of the year. But also we think about it from within the building and how do we take carbon out of construction of the building. So this idea of if you don't need it, take it out. So this is Nightingale 1, and we've taken out the ceilings, for example, and so you can see all the fire services running through there and the electrical cables. We've taken out all of the services cupboards, so you can see the water meter assembly in there. It's about an exercise in reductionism rather than an exercise in addition. The bricks on this building are recycled, so there's no carbon associated with those bricks there. The upholstery that this woman is sitting on is 100% recycled polyester, so it's made from respun PET bottles, so old Coke bottles respun into fabric. Each of those moves is made to make sure that we're taking carbon out of the building through construction. This idea of building less to give more. So Nightingale, for example, we think about what are the things that you actually need. And when people ask us about the ideal living environment for them, they talk about space, light, height, views, fresh air. What they don't talk about is 4 bedrooms, 4 bathrooms, 1,000 downlights, a marble bench top. They're not the things that people actually want. They want housing security and they want simple things that make it feel like home. So in Nightingale buildings, we took out all the second bathrooms. So in all the 2-bedroom apartments, there's a well-sized, good bathroom. And so we took out, 20 bathrooms, all the en-suites that we don't need. And think about all the embodied carbon that comes out of that, and then think about how your living room then gets bigger. And then we took out all the individual laundries. So again, the living room gets a little bit bigger, and we put an incredible rooftop laundry on the top. And we have 6 shared washing machines for the residents and this beautiful laundry that overlooks a rooftop garden in the city. And there's, instead of having, 24 washing machines in the building, you've got 6 together on the roof, and bulk washing liquid and bulk fabric softener for everyone to be able to use. So you get a bigger apartment, you get lower appliance costs, you get lower operating costs in your apartment, and you share, you share things, which is a nice idea, right? Size matters. So Australia has some of the biggest housing in the world. The funny thing is that our occupants per dwelling has been dropping since 1910s. We have less people living in a house, but our houses are getting bigger. So, today each Australian takes up, 8 times more space than they did in 1920. And where do people need to live? Near their community, near their family, near their place of work, near their place of education. And so we tend to build, where you build housing is incredibly important. And I know that people complain about density, but density done well is the only responsible thing to do. Building at the edges of our city, on our farming land, on our forests, that's the surefire way to destroy our entire environment. We've already built over 40% of our agricultural land in Australia, which means we're now buying food back into our cities where we've built over the places where we used to grow food, which puts us under incredible food security risks in a planet with a changing climate. So we tend to focus on building in the right places. So we tend to build close to train stations, close to bus terminals, close to tram lines, close to activity centres, shopping strips, close to places of education or hospitals and schools. So they tend to be more urban environments. And then we like to build buildings that are about 5 to 6 stories, which is kind of a good medium rise height. You can see the street, you can engage with the people on the street. And we've seen incredible examples of good sized apartment buildings that have kind of made up of, apartment numbers between kind of 20 and 40. We've seen great examples of that across great European cities like Barcelona, Rome, Berlin. We use recycled materials wherever possible because we know they've already paid down their carbon in a previous life. So in this instance, this recycled timber floor goes all the way through Nightingale 1, and it's top nailed, not glued, which means at the end of this building's life, this floor can be reused. There's recycled content in all of our concrete throughout our building. So we still use concrete. We haven't found a way to move to mass timber, across all of our buildings yet. And so with the concrete that we use, though, we keep on improving how much recycled content that we have in our building. And in the latest building that we're working on, we've got 46% cement replacement, which means we don't have virgin Portland cement, which is incredibly high in embodied carbon. Instead, we're using fly ash and slag, which are byproducts of the steel industry. We're using crushed glass or silica instead of virgin sand, and we're using recycled aggregates, so recrushed concrete and recycled water to make our concrete for our new buildings. So in the next building that we're working with, we're hoping to get that above 50%, and we keep on trying to make that better. We try to use materials as close to the natural state as possible. In this instance, there's some, you can see recycled bricks, but there's also bluestone on the floor there, so Australian bluestone. We use local materials, so try to source, Victorian pine out of a Victorian plantation, if we're specifying that, or if we are using stone, then we try to make sure that it's Victorian bluestone. Materials with low embodied energy. So we look at how much carbon is associated with the production of the materials that we're using, and materials with low toxicity. There's no point building a building if it's going to kill its occupants. So, for example, we haven't used enamel paints in 20 years. We all use water-based, very, very low VOC paints. We use a wax finish on our floors it's incredibly low VOC. So we want to make sure that our internal air quality is healthy. Lastly, step 3, the most important thing that every one of us can do is buy 100% credited green power. So, talk to you again, please write it down, do it after this session, call your energy provider and ask to change to 100% certified green power. They'll offer you 10%, they might offer you 30%, and say you want 100%. So the thing about green power is that it's a vote for a renewable future. When you buy green power, it is the market signal to change our energy mix from coal, both brown and black, and away from gas to renewables, large-scale renewables, solar and wind. So if we can't wait for a federal government to set a new renewable energy target, then we need to do that internally. Buying carbon neutral power or carbon offset power doesn't resolve that, because it's just a power company buying offsets internationally. Whereas when you buy 100% certified green power, it directly results in new renewable energy projects in Australia. Thank you very much.
Wow, Jeremy, that was really, really insightful presentation. There's a lot that we can get out of that. And I think the way you sum it up, it's it really is the basics. There's the basics of the design. There's the basics of the functionality of the design as well, just simple measures people can do. And then there's also the basics of action that people can take. And that's as simple as jumping on the phone and calling your electricity provider to change your supply of electricity to accredited green power. It's no pun intended, it's not rocket science.
Yeah, if you couldn't do any, if you couldn't do any of those things, if you just switched to 100% certified green power, if we all did that, what we would see over the next 5 years is a drastic change in our energy mix, and the way that energy is produced in this country, despite what happens at a federal government level, because it would be market driven. And so, we have to electrify, and then we have to change the way that our energy mix is generated.
Yeah, exactly. And I think we're starting to see that change now.
Yeah.
I mean, obviously there's a lot of discussion on the news and through the media about the federal government's position on everything from renewables, energy security, energy supply. It's been a discussion for a number of years now, but it's really starting to come to that pinch point. So I think that the tribe is speaking, and everyone's listening and everyone's watching. So we're in a really interesting space. So it's just a case of that progress being in the right direction. I'm just going to see with our participants if we've got some questions in the chat. It looks like I do have a couple that have popped up. I've also got a few myself as well, Jeremy, but I'll go through these first. I've got one from Alex here. How do you go about doing things correctly? If I'm to build and don't know what I can do, what I can do to do it correctly, who can I talk to?
Yeah, it's a good question, Alex. I think that, like I said before, I think that architects now are in a good position to understand sustainability. I had to go to Tasmania to study an undergrad in environmental design, whereas I now teach at Melbourne University, and every student coming through has an understanding of sustainability. So I think that the key thing when approaching the building of something big, and building a house or building apartments or building a building is a big, expensive thing. And so the key, in my view, as an architect, is obviously to make sure that you get the design right. The interesting thing about thinking about sustainability from the very, very start is that Nightingale 1 proves that it doesn't cost any more. In fact, Nightingale 1 was delivered 19% under market. So it was sold, like the 2-bedroom apartments there were sold $90,000 under market. And that won the National Award for Sustainability. So it's carbon neutral in operation. It was 8.2 stars on average, well above the 5-star requirement. And people living in that building are paying about, in one-bedders, between $20 and $28 a month for electricity. And in the 2-bedders between $35 and $45 a month. They don't have a hot water bill, they don't have a heating bill, because that's all covered through the heat pump on the roof and the solar array. So to live in those buildings becomes incredibly affordable. But I think, Alex, back to answering your question, the reason that all of that worked for Nightingale 1, for those residents, is because the design considered embedding simple moves about sustainability from the outset. So, I often hear people saying, oh, look, I want to save some money. I'm not going to get an architect. I'm not going to get a designer. I'll do it myself, or I'll just get a draftsperson to do it. But I think that the thing is that if you are buying a car, you don't go to your mechanic and say, listen, I need 4 wheels and a steering wheel and ideally some brakes. You know, can you just kind of make one for me? When you buy a car, everything has been considered about how the whole thing goes together. And so the design of the car is paramount. Building a house is the same thing. So I guess, Alex, what I'm saying is get it designed, think through everything first, get everything priced before you embark on a building project. Building is not like grand designs. It doesn't need to be dramatic. It can be incredibly straightforward and boring. The trick is get a good architect or a good designer, get a good builder, check all their references, and then sign a contract that you can afford to build on. And then make sure that those professionals see it all the way through. It's actually incredibly stress-free and not dramatic at all, I'm sorry to say.
I think that pretty much sums it up there. Speaking of the design as well, I mean, it's fundamental, and yeah, there's terms around sustainable design and concepts of sustainable design. It sort of seems that it can be really technical and complex, but the way it's portrayed, and you just have to look at the examples of Nightingale and a lot of your projects actually, it's simple and good design. It's there's nothing complex about it. It's just well thought through, and that's from our role as sustainability, in particular with planning. That's really at that early stages of concept. So that's where sustainability, or at least the principles of sustainability, just need to be considered. And it's amazing.
Absolutely,
amazing
James.
benefits.
I mean, the funny thing about Nightingale is that, you know, the balcony depths vary on the north and the south side. So the northern balconies, you know, are designed to shade in summer but allow winter sun in. We do a lot with vegetation. So the northern side is covered with deciduous ornamental grapes. So the north side of the building, you know, has these incredible kind of lush green vines that grow over the whole facade. And in autumn, they change color. They go red and golden. And then in winter, they drop their leaves and you get this kind of incredible winter sun penetration deep into the apartments, hitting all of the thermal mass, which is exposed, all of the concrete's exposed, and it heats the whole building for free through this kind of really beautiful lattice work of kind of, you know, of the spines of kind of grapevines up the building. It's incredible.
Yeah, it looks really beautiful. Yeah, especially when you go through the seasonal change now, and it just adds to the amenity as well as the design. Speaking of the design as well, I'll just ask one more question before, because a couple popped up in the chat box. With, as you mentioned, the NATAS rating being so high, sort of beyond 7.5 to over 8-star, and Melbourne obviously being predominantly a heating climate. A heating climate. We've had a few. We obviously get some bitterly cold days in the middle of winter and bitterly cold nights. And then at the same time, we do experience the really brutal heat waves in summer. And I mean, these projects have been around for a number of years, and we have had a number of heat waves during that time in Melbourne. How do the buildings cope in terms of the need to heat and cool them during those temperature extremes?
Yeah, that's a really good question. So I live in the Commons, which is the prototype building, the one that you've been through. And so I've lived there since December 2013. And basically the way that it works is that we expose all of the thermal mass like a cellar. So the concrete ceilings are exposed, the precast concrete walls, the structure is exposed. The outside of the building is insulated incredibly well, like an esky, if you will. All the windows are double glazed and thermally broken. And then the windows facing north and west are well shaded so that we know when we're going to get the heat gain. So, you know, we don't get any direct heat gain or very, very little direct heat gain from the sun hitting the glass or getting inside the apartment. You do get it from kind of ambient air temperature kind of rising. So over a heat wave, if the nighttime temperatures don't drop, you know, that becomes challenging over time. But fundamentally, the way that we use our apartment is the way that that my grandparents use their house, which is you need to be aware of what the climate is doing. And it's helped me reconnect with what's happening with the climate and the weather. So, you know, I don't just flick a switch and never worry about it. I look at, you know, weather zone and say, oh, it's going to be 35 today. I'll close all my windows, you know, and then I go out, and then at nighttime, I'm like, oh, it's dropped to below 27. I'll open my windows again, you know, or in the evening. So really it's about in those temperature extremes, Like when it peaks past 27, we close the windows. And when it drops below about 15, you close all the windows. But apart from that, you just use your windows as a mediator, because Melbourne generally has this great kind of diurnal shift. So big daytime temperatures and lower nighttime temperatures. And so while concrete as a thermal mass has a lot of carbon in it, it also becomes an incredible stabilizer. So instead of the daytime temperatures, the nighttime temperatures kind of, and your internal temperatures fluctuating, what the thermal mass does, it kind of absorbs the daytime temperature, and then it absorbs the nighttime temperature, and it flattens out that. So we get a very, very stable temperature inside. So I guess it's a lot like a cellar, James. It's incredibly stable. So kind of between 19 and 22 for kind of, 95% of the year. And we've got, some PhD students, a PhD candidate, Katie Skillington from Melbourne University, with temperature sensors in a number of buildings like the Commons and Nightingale, testing that kind of long-term temperature range.
Yeah, it's pretty amazing. I mean, my house leaks like a sieve. So as soon as you turn the heating or cooling off, within a couple of hours, you're almost at the outside temperature. So, you've got benefits of thermal comfort, and then most importantly, your energy bills are significantly low, because you just don't have to heat and cool. You don't have to condition the air. It's all done naturally for the majority of the year, which is fantastic. I'll pop down to a couple more questions here that have popped up. This one's from Jess, and this is, hi Jeremy, what are your thoughts about the role of growing food in urban environments in the transition to net zero?
Really good question, Jess, and I've been historically a really big fan of this. What we have seen though, particularly with climate change and kind of and heat wave events, is that like our rooftop gardens at the Commons in the first couple of years, if you had 4 crops, the summer crop would fail, because you get like a heat wave event where you'd get incredibly hot winds from the north. And so what we learned from that was that we then changed the rooftop garden, the productive garden position, from the north side of the building, which seems to make intuitive sense, to the south side of the building. So because our buildings are elevated, what we're finding is making it challenging for the plants up there is not enough sun or not too much sun, but it's actually the wind. So damaging hot winds. So in Nightingale 1, the rooftop garden is in kind of more of it's almost like a greenhouse situation, and those gardens are thriving. And obviously it works for a number of reasons, obviously for food production, but also for residents to help build community. So they come together around that. But my view on this is that, Joost Bakker is a good friend of mine, and I've seen what he's done with future food systems. But I think that the answer is that we really need to think about how we do this at scale, particularly given that we have built over 40% of our farming land in Melbourne, and our population is growing rapidly. So I think that we really need to look at, like Brendan Condon's looking at the greenhouses on the rooftop of the car park in the city of Melbourne, large format greenhouses. We need to look at 10,000 square meters of greenhouse on the rooftop of buildings, linked together, so that we can actually then start to bring in professional farming linked in with some of the communities, to make sure that we can actually get the yields that we need and the kind of nutritional value we need out of that production. So at the moment, yes, I think it's still fledgling, but I think it's incredibly important, and we've got to find a way to professionalize that, I think.
That's a good point. There's a part B to that question as well, but while we're actually just on the subject of food, and also the sense of community aspect with the design and those communal areas as well. Obviously we had the experience with COVID, and in particular the lockdown in Melbourne, and the isolation that we all had. And we also saw a lot of people dabbling into growing their own produce in their own backyards and balconies and that sort of thing. In particular, the sense of community, how valuable was that in the height of the pandemic last year?
Incredible. So in Nightingale, Brunswick East, the residents organised COVID bubbles on their floor levels. So particularly the floor levels with kids, so that they could come together in clusters with kids. And so they would be going, and there's a couple of different rooftop levels there, and so they could come together stay sane and the kids could play, you know, on their floor level. So they kind of locked that down and made COVID bubbles there, which worked incredibly well. Nightingale Brunswick East, such an incredible community, they also organised fashion parades. So everyone would stand inside their apartment door, where they wouldn't step outside into the lift lobby, but they would look out, and then people would be, you know, kids as well, kind of walking up and down, like, you know, one at a time, having a fashion parade in the lift lobby. At the Commons, we had a series of, you know, one of the apartments, apartment 102, had a series of concerts on their balcony where they would play music, you know, each Wednesday night in different themes, and put up flashing lights and everything. And then everyone else would come to their balcony, and they'd even print little posters and put them up around the building, like, here's this great concert on Wednesday night. And then people in the building opposite, which was Nightingale 1, and other buildings, were all coming out to their balconies to watch a performance on the balcony of apartment 102 every Wednesday night for 4 weeks. It was absolutely incredible, and like everyone dancing on their own in their own balconies. So it was incredibly joyous, actually, you know. And then people playing, you know, like Staying Alive and stuff, you know, early on Sunday mornings out of their apartments. So it did feel like there was a lot of resilience in those buildings with a strong sense of community connection.
Yeah, it's the sense of community. There's been a lot of resilience out of that. I mean, I just live in a detached house, and but we all know our neighbourhood a lot better. And all it took was a global pandemic to bring us together.
It's so incredible, isn't it? Maybe yes, it's exactly what we needed.
It's amazing. Yeah, it's amazing how now we do look out for each other a lot more. We're a lot more social. We sort of we're all in our own little busy bubbles and that sort of thing. But that's just the benefit of these kinds of developments. It just really, that sense of community was already developed. You're seeing your neighbours every day, and now that bond is even stronger. So
yeah, and actually in Nightingale too, they built this really stringent cleaning roster. And so everyone just took their time, or took their turn, you know, going up and down the building, so that, you know, everything was cleaned on a daily basis, you know, everything was sanitized, and it was the residents doing it. They didn't pay for an external cleaner. They just handled it themselves. They all came together and did all the heavy lifting themselves.
Yeah, it's amazing, the resilience and just the benefits out of it. I'll go to the part B question. This relates to embedded networks and back to the energy side of things and emissions. So how does the embedded network function at Nightingale 1? And is this run by the owners corporation or a third party provider?
No, absolutely, great question. Absolutely through the owners corporation. So which is key, right? So the problem with embedded networks historically was that there would be a third party that would run the embedded network, insert themselves between the energy retailer or the energy wholesaler and the residents. They would buy bulk, and then they would charge as much as the market would bear to the residents and clip the ticket and make their kind of profit margin between the retailer and the end user. In Nightingale buildings, the embedded network is owned by the owners corporation. They employ a kind of embedded network manager, and Nightingale negotiates the bulk purchase price between all of Nightingale buildings. So we have an agreement with Momentum Energy to buy 100% green power at bulk rates, and then we share that rate, that contract rate, back with the residents. So our residents, the beauty of the embedded network is that they get 100% green power cheaper than anyone else gets black power in the suburb. And then on top of that, it means that it's really easy through the embedded network to share the solar benefit with all the residents. So, you know, once the solar is being tasked to hot water or to heating, beyond that, that solar benefit just gets shared directly with all the residents. So yeah, it's an embedded network used for good, not evil, is actually a really great thing. And you know, so we just commit, you know, all of our embedded networks through our owners corporation rules to only buy 100% certified grain.
I suppose just on that, are those contracts more of a long-term contract, or I mean, it's a bit of a technical space. I only say that because our Greater Dandenong's recently joined multiple power purchase agreements, actually. And one of the bigger benefits of that is it provides long-term certainty. So there's the volatility of electricity prices, but it's obviously it provides a longer-term level of certainty for the user.
Absolutely. So we enter 3-year contracts at Nightingale, but we also have a very, very good relationship with Momentum, so that it gives us, obviously, if we've got a good working relationship with our partner, we can talk about should we change that, and also if they want to put in a virtual power plant or they want to put in a battery, to work out, can they test spot pricing or can they use that as a kind of local area network? We're totally happy for them to look at innovation with Nightingale, because we want to help them be part of the energy solution. We want to help them be part of an a fossil fuel free electric generation, network.
That's fantastic. There's a few more questions that have popped up actually, because that'll almost see us through, I think, till the end time, which is approaching not too far away. This one's from Steph, and it says, "Hi Jeremy, going off Jess's question with regards to green walls, obviously great for cooling buildings and absorption of carbon dioxide. Is the damage that they can cause to buildings over a long period concerning, or if built correctly, can they not damage the integrity of the building at all? And they do look amazing to top it off, and I certainly have to agree with that in terms of their looks."
Yeah, great question, Steph. So we don't use English ivy. So English ivy is quite destructive because its roots actually get into kind of mortar joints, for example. But we use things like Ficus pumila, or it's just ficus. We use Boston ivy, which again can be destructive if it gets into cracks. But when you're putting it onto precast concrete, there are no cracks. And the beauty of putting, Boston ivy and ficus on, and so we use those in different ways. And they're both incredibly robust. They're both very, very fast growing. We use ficus when we're covering a commercial building, or when we want to make sure that we've got it's an evergreen, so that gives us year-round shading to our facade. We use Boston ivy when we want winter sun penetration, so we use that more for residential. An apartment building would be more likely to use Boston ivy. So in summer, it shades all of the precast, perhaps to the west or something like that, or our concrete walls. But then it loses its leaves and we get sun penetration, and it starts to kind of, give us some solar benefit. But I mean, it's incredible looking at the temperature of a wall that doesn't have, plants growing on it, compared to the temperature of a wall that does. Like it's like, one's, 25 degrees and one's, 45 degrees. It's fascinating.
Yeah, you mentioned Boston ivy. It's I only just discovered it recently in terms of its effectiveness and the fact the way it grows really quickly, and
it's so fast. Yeah,
it looks amazing as well. Especially, I say this time of year, about a month ago, it looked amazing as all the leaves were just beautiful, beautiful colours.
They're obviously both introduced species, and they're both climbers. But you can get indigenous species that are more like that they won't necessarily cling to masonry, but they'll climb up, a trellis or wires or chains. So, you can use a bunch of other things, but just think about what is it that you want. Do you want evergreen? Do you want deciduous? And deciduous can be incredibly powerful, a powerful tool near glazing.
Yeah, definitely agree with that. I've got a couple more questions here. Let's see, we've got just reiterating the benefits of the embedded network. And yeah, a lot of praise, Jeremy. Everyone's really enlightened with the presentation. So there's so there's clearly a lot of people are pretty happy with that. I have one here. Hey Jeremy, question I had was curious of what can we do about commercial buildings or accommodation buildings that have obviously been built, for example, 30 years ago, and that obviously doesn't operate on electric. Reverting to the gas approach there. How can these older buildings be changed?
Yeah, that's a really good question. I mean, this year's Pritzker Prize winner, so that's like the peak prize for architecture in the world, is L'Habitat Basel. It's a French company. They're architects that do social housing, and their whole approach is never, ever, ever to demolish. It's always about how do we keep an existing building and use it, because they're incredibly aware of the embodied energy in that existing building. So I think that the first thing is that we need to stop our addiction with demolishing old buildings and thinking we have to build new. We need to capture the embodied carbon in the structure that's in that existing building. And then we need to think creatively about how we adaptively reuse that. So our view on existing infrastructure and buildings is that if the infrastructure is relatively new, so if there's gas infrastructure and there's a lot of it in there and there's a lot of embodied carbon in that infrastructure, then we will leave it, and everything else that we'll put in there will be 100% electric. And then we will design a pathway when that plant and equipment is being retired to replace that with a CO2 heat pump. If everything is nearing the end of its life, then, basically, you would use the existing structure, you would insulate that from the outside, you would use the existing structure as thermal mass. And the great thing about commercial buildings is that they're generally not strata titled, so they're kind of easier to handle. The problem with our strata titling in this state is that it's very, very difficult to get agreement for an owners corporation to do a massive refurb. So I think that we're going to have to work out how we're going to deal with that, because we've got a lot of buildings with a lot of individual title holders, which is going to make it complex for us in the future. But I think that, the answer is that we have to go all electric in the future. It's just, if you think about, issues with the fire in our Lacrosse building or Grenfell in the UK, if you were to take all the gas out of a building, that's got to be a good thing, right? Not just from an environmental point of view, but also from a fire safety proposition. So yeah, I think that, keep it if it's new. If it's not new, it's time to replace it with all electric and find a way to reticulate it.
Yeah, I totally understand that as well. But I can revert that to my own experience. When we first got our house several years ago now, the gas ducted heating unit died and needed to be replaced. And I did replace it with the same gas ducted unit, but it was probably the biggest mistake I've made with the house in terms of upgrading, because all I could have done was put in some reverse cycle units, because despite it being a very efficient 6-star gas ducted heater, my gas bills actually, I've broken off half the amount of gas usage, but my gas bill is virtually the same as what it was. So the costs are actually going up for us. And also, that said, which probably goes back to another question about gas, you mentioned the induction cooktops as well. That's always one of the most commonly mentioned myths about cooking. It's easier to cook with gas and people prefer to use gas. I've grown up with a gas house, gas cooking. The house that we did move into has an electric cooktop. It's not induction, but it's that one down that looks like an induction cooktop, but it still has the heat plate underneath. So it's certainly not as energy efficient as an induction cooktop, but it's actually just as effective as a gas stove. Yeah, I might have to wait another minute or something for it to warm up, but apart from that, there's no difference. It's actually easier to clean.
I think everyone who says that it's easier to cook with gas has just never cooked with induction. So when you put a ferrous-based pot on a induction cooktop, it's the magnetic field in the induction cooktop interacts with the metal in the bottom of the pot, and so there's no heat generated on the plate. It's just heat generated directly in the pot itself. Like, it is incredible. So you don't lose any efficiency through those things, and it's super, super quick. So yeah, I think that Fisher Paykel are a Nightingale partner, and they run an induction session for the Nightingale residents when they move in to teach them how to use it. And the residents are just like, far out, this is incredible. So yeah, for any of you, get down to one of the who aren't sure about it, get down to one of the retailers and ask them to see induction being used, and try induction. But it's incredible.
Yeah, and I mean, the fact all appliances you buy at the shops now are all induction friendly, so there's no excuses really. It's so easy to transition. So highly recommended as well. I might have this as the last question. It's almost 10 to now. So this one's from Lily, and it's a more general question. What are you hopeful about for our future? Obviously, there's been quite a lot of negativity at the moment in the world of COVID and climate change, and sort of all the doom and gloom, and bad news sells bad news sells, unfortunately. But what's one thing that you're hopeful about in the future?
Lily, I'm actually hopeful about so much. So, again, I'll go back to 2001. I was one of 6 sustainable architects in Melbourne, and now every architect is talking about sustainability. The Institute of Architecture has 12,000 members. It went carbon neutral last year. 800 of Australia's best architects went carbon neutral last year as an organisation. The Green Building Council are working with, volume builders to build carbon neutral homes. So while I'm not that hopeful about, policy coming out of federal government, what I'm seeing is that, in Victoria, in Melbourne, I'm seeing incredible kind of steps forward. Internationally, out of the American Institute of Architects, out of the Royal Institute of British Architects, out of countries like Norway and Sweden and Denmark, incentivizing electric cars and disincentivizing internal combustion engines to the point where over 55% of Norway's cars are EVs. Companies like Tesla, that everyone thought was a joke when Elon Musk started it, this idea that we had to electrify the world, and now he's become like one of the most wealthy men in the world, and he's never built cars before. And everyone who was only building internal combustion engines are now scrabbling to try and reposition themselves. We've got companies like Patagonia who have changed their mission statement from the world's best climbing equipment to the company that wants to save the world. Mike Cannon-Brookes at Lassian, dedicating large chunks of, his fortune to sustainable, investments, and that's happening everywhere, like, from Gates to Warren Buffett, so I feel like, and now we've just had, an election in the United States. We've had, a change in government, and we've got an incredibly aggressive kind of, climate strategy from the US, and we've got a conservative government in the UK that is talking about, beating their Paris climate commitments. That's the conservative government there, talking about knocking it out of the park. And we're seeing incredible traction made by the UK government, the conservative government. So I think, Lily, I think we've been paddling up the back of the wave for a long time. And I think that we're finally on the crest of the wave, and we're going to be able to, get up on the board and enjoy the ride. So you look, everyone who's here, I know you're all committed to this. And also I think that there's generational shift, right? As baby boomers lose power, and as Gen Xers, particularly as millennials, start to get power, whether it's in the corporate sphere or in the political sphere, we are going to see a massive shift. Because you can see that some baby boomers can't give up their addiction to fossil fuels, whereas millennials don't understand why we were there in the first place. So I think that there is going to be a massive changing of the guard.
Yeah, absolutely. And I think it goes back to the point that actions speak louder than words. And we're starting to see that action now in the last few years, which is just building and building. And like technology, like our phones, 10 years ago, everyone was carrying around a brick in their pocket. And now it's just that wave, the wave effect. And strap yourself in and let's enjoy the ride. It's a mixture of all of policy, action, technology, but it's the power of the people as well to make it all happen. So
I think that's the big thing, right? That we as individuals get to make incredible decisions through our market choices. Whether we're eating vegetables or red meat is a choice, right? And it has a massive impact on the way that the big commercial shopping centres start to stock their shelves. The energy that we buy makes a massive difference. The cars that we choose to buy, whether it's incentivized or not by the government, we get to make those differences.
Absolutely. And that's reiterated in the chat as well. Everyone's feeling a lot more positive after that. I am as well, Jeremy, and I think everyone here viewing it was positive today. I think we'll probably leave it on a very positive note and an inspired note. We really appreciate your time this afternoon. It's almost time for our next presentation, actually. Once again, Jeremy, on behalf of Greater Dandenong, we really appreciate the time this afternoon. And
I love the work that Greater Dandenong are doing, James. So you should be very proud as an organisation. Keep it up.
Thanks very much.